All right, recording is rolling. Welcome to Thursday, October 19th. I got a story for you guys today. And then you guys remember your chapter 6, 7 puzzles are due tomorrow. We've covered them all in class, so as long as you've been following along, I think you'll be all right. Okay. I gave you guys a new quiz yesterday, so let's have that due on Monday. So have a few days to do that. Okay. Any questions on any of those things? All right, so Fermi paradox. How many guys have heard of the Fermi paradox? Fermi paradox. Oh no. Oh, okay. Then today's a great day. Great day for you because it's one of my favorite stories. Okay. All right. So I did have a PowerPoint. I was going to show some pictures as I go along. My computer is not connecting to that projector right now. So instead, here's what we do. We're just going to zoom in on this. We're going to freeze my screen, and this is a pretty good graphic for what I'm doing here. All right. Our night sky. Yeah. So when you guys look up this part of the story, but just for context here, okay? When you guys look up at the sky and you like see a bunch of stars, like maybe like hundreds of stars. Okay? Has anybody ever seen the night sky like where there's no light pollution, like way out west where there's no light pollution? How many guys? Uh, oh, so a couple of guys. Yeah, a couple of guys. Right? Yeah, because you think about like in the context of the larger history, like first couple of days of class, I want to give you guys the context, like where we are, like in the wider scheme of history, right? For like thousands and thousands and thousands of years, like there was no light pollution. When night rolled around, what could you really do at night? Probably not very much, other than like stare at the sky, stare at the stars. People could read the stars the same way you could read a book, right? Like you open up a book, you see words, you immediately know, you can interpret, right? Back in the day, and people look at the night sky and to see the constellations, immediately know probably within like half a second which way's north. And you could do that like 1,000 years ago because people are just that familiar with the night sky. Right? Nowadays, like if you live like where we live, there's so much light pollution, you don't see nearly as many stars. Right? But even if you do like go say um, like out to Colorado, the middle of nowhere where there's uh, hardly any light pollution. Okay? All the stars you really see are, um, well, if you could see our Milky Way galaxy from above, which obviously we don't have a picture of our actual Milky Way galaxy from this angle, right? But just as a representation, it would all sort of be inside that little tiny circle right there, right? Just to give you an idea of scale, right? There's like so I think at least 100 billion stars in our galaxy. Okay, so let me go ahead and freeze my screen right there. Freeze that picture. Okay, there we go. All right, and then I got a story for you guys. A story. All right, so this is an essay by Tim Urban. I think about 10 years ago, so he wrote this. Says everyone feels something when they're in a really good starry place on a really good starry night, and they look up and they see this. He's got a picture of the night sky here. Some people stick with the traditional feeling struck by epic beauty or blown away by the insane scale of the universe. Personally, I go for the old existential meltdown followed by acting weird for the next half hour. But everyone feels something. Physicist Enrico Fermi felt something too. He asked the question, where is everybody? A really starry sky seems vast, but all we're really looking at is our very local neighborhood. On the very best nights, if you get away from all the light pollution, you can see up to about 2,500 stars, which is roughly 100 millionth of the stars in our galaxy. Almost all of them are less than 1,000 light years away from us, or 1% of the diameter of the Milky Way galaxy. So you're really seeing that, right? So yeah, so you guys in class, that's where that image comes up. I guess if you're watching this video at home, then well, sorry, I don't have an image. Have to use your imagination there. Right. Here, a little bit more context here. He's talking about so this is called Fermi paradox that I'm about to begin into. He's talking about this physicist Enrico Fermi. Did I tell you guys about this guy, Enrico Fermi? So how many guys over the summer watched a movie called Oppenheimer? You guys watch that? Oppenheimer? Okay. So there's, of course, a bunch of nuclear scientists working on the Manhattan Project back in the 1940s. This is one of the scientists. One of the stories I read about this guy, Enrico Fermi, was that when the nuclear bomb went off, one thing that he did was, as he was waiting for the blast wave, he held out some paper, okay? And he dropped the paper and let it flutter to the ground as the blast wave came across. And he looked at like how far horizontally did the paper flutter as it was falling to the ground? What height do you drop it from? What do I know about the properties of air? Right? How far am I away from the like from that nuclear blast? Right? And he crunches all this math to get a pretty good estimate of like how many like tons of TNT equivalent was the blast, right? He was just getting an estimate, just watching his paper flutter to the ground. It was actually not that far off. He's pretty close. He liked to make estimates of this all the time. So you can ask like any crazy physics question that is like, well, how could I possibly know the answer to that? You say, well, okay, well, here's maybe some things I do know or could estimate. Maybe I'll overestimate or underestimate some variables. But I can put it all together at the end and come up with a pretty good idea. Right? And when he's asking the question, like, where is everybody? He's saying, well, this universe is so big. And then later on this essay, also so old. A lot of people forget about that dimension too. Right? So big and so old that Fermi says, it seems mathematically overwhelmingly likely that we would have had contact with alien life by now. So, if that's not well established, then why would that not be? So that's the paradox, right? That's the paradox, right? There's this mismatch between the math saying it's overwhelmingly likely to be the case, and then our observations saying, well, we don't really have a definitive answer saying that that's happened. All right, so here we go. Back to this essay. When confronted with the topic of stars and galaxies, a question that tantalizes most humans is there other intelligent life out there? So let's put some numbers to it. All right, so now we're going to go through Fermi's thought process. Right, we're going to start with, okay, again, I can't project my screen, but he's about to reference something called the Drake equation. He doesn't actually in this essay use the term Drake equation, but that's kind of what he's talking about. So you're going to take like a huge number of stars and just multiply it by a bunch of ratios, right? What's the percent of stars that have say habitable conditions or Earth-like planets, and then likelihood of life developing, right? Goes through all these ratios and comes up with a number at the end, like how much life should there be, and then the last step might be like, what's the percent chance they like make contact with us, right? So, all right, here we go. We're gonna kick off this process. As many stars as there are in our galaxy, somewhere between 100 billion and 400 billion, there are roughly an equal number of galaxies in the observable universe, right? You guys see that picture up by my door? Did I tell you guys that's the Hubble Deep Field? Right? That's as far as we can see. That's like the edge of the observable universe. There are almost certainly galaxies beyond that, but they're just moving away from us so fast, and light has a limiting speed that we can't physically see anything beyond that. Right? Nobody knows how big the universe is. There's a good case to say that it might actually be infinitely large, which would have some crazy implications, but there's like an observable universe, right? Right. So for every star in our own galaxy, there's a galaxy out there in the observable universe. Altogether, that comes out to a typically quoted range between 10 to the 22 and 10 to the 24 total stars, which means that for every grain of sand on Earth, there are 10,000 stars out there. The science world is not in total agreement about what percentage of those stars are sun-like, similar in size, temperature, luminosity. Opinions range somewhere between 5 and 20%. Let's go for the more conservative side of that, say like 5%. And the lower end of the number of stars, say 10 to the 22, multiply those two together, that gives us 500 quintillion, which is 500 billion sun-like stars. Presumably, if you had a sun-like star, that would be more favorable to conditions for life, right? There's also a debate over what percentage of those sun-like stars might be orbited by an Earth-like planet, one with similar temperature conditions that could have liquid water, right? That's probably a good case for life, right? It's probably have to have liquid water, right? And potentially support life similar to that on Earth. Some say it's as high as 50%. Let's go with the more conservative 22% that came out of a recent PNAS study. There's also a potentially habitable, that suggests that there's a potentially habitable Earth-like planet orbiting at least 1% of the total stars in the universe, a total of 100 billion Earth-like planets. So for every 100, so there are 100 Earth-like planets for every grain of sand in the world. Ooh, think about that next time you're on the beach, right? Go to the beach, you pick up one grain of sand. It's going to represent there's 100 Earth-like planets somewhere out in the observable universe. Moving forward, we have no choice but to get completely speculative, right? So far, he's got some estimates that are based on observations, but now it's like, well, okay, now these next estimates are a little bit more subjective. Let's imagine that after billions of years of existence, 1% of Earth-like planets develop life. Okay, so that again, completely speculative number, right? Like how often does life even develop? Right? That's pretty pertinent to this question. 1% of so we're going with 1% of Earth-like planets develop life. If that's true, then every grain of sand on the beach would represent a planet with life on it. And imagine that 1% of those planets, life advances to intelligent life like it did here on Earth. That would, so if you got life developing on all these planets, how often does it get to the point of like, there's some beings that develop like writing and technology and all this, right? That would mean that there are 10 quadrillion or 10 million billion intelligent civilizations in the observable universe. Moving back to just our galaxy, right? Because all these numbers so far is done for the wider observable universe, but let's just put it just in our galaxy, right? Maybe that's more contained math to do. Right? And doing the same math, the same proportions, lower estimate number of stars, right? Milky Way galaxy, at least 100 billion stars there are. We would estimate that there are 1 billion Earth-like planets and 100,000 intelligent civilizations just in our galaxy, right? So 100,000 intelligent civilizations. SETI, which stands for Search for Extraterrestrial Intelligence, is an organization dedicated to listening for signals from other intelligent life. If we're right that there are 100,000 or more intelligent civilizations just in our galaxy, and even a fraction of those are sending out radio waves or laser beams or other modes attempting to contact others, then shouldn't SETI's satellite array pick up all kinds of signals? But it hasn't, not one ever. So where is everybody? Should, as a side note, I made some side notes obviously in this essay. There have been like a couple of weird signals over the history, but nothing has ever confirms like, oh, well, that's definitely like intelligent life sending that, right? It gets stranger. Our sun is relatively young in the lifespan of the universe. There are far older stars with far older Earth-like planets, which should in theory mean civilizations that are far more advanced than our own. As an example, let's compare our 4.5 billion year old Earth to a hypothetical 8 billion year old planet X. So you guys probably know do you guys know how old is the universe considered to be? There's kind of a standard textbook conclusion. Does anybody know? Right. So, do you guys know like how they would even like come to that number? Right, like how old is the universe? So it has to do with like Doppler shifting. You guys know if a car goes by on the sidewalk, it sounds like meow. Right, you hear a pitch shift, right? Now, if you're in the car, you don't hear the pitch shift. You're standing on the sidewalk, you hear that pitch shift, right? No, that's sound waves. Light works similarly, but you'll see a color change. So different colors of light are associated with different wavelengths. Now, if you look at distant galaxies, they're actually red shifted, which is an indication that they're moving away from us. The light stretched out. If you calculate how much light stretched out, you can figure out how far away they are and how fast they're moving away from us. Okay? So if you wind the clock backwards, then you can say, well, when was everything at one place at one time? And the answer pretty universally tends to be approximately 14 billion years ago, is usually never here, somewhere between 13 and 14 billion years ago. Right? But our own solar system is only like 4.5 billion years old. The way they know that is looking at the very oldest rocks, say on Earth or in our solar system. Right? If you look at radioactive materials, like one radioactive element is uranium. This is all not in the essay, but it's just how they know this or how they come to this conclusion. Okay? One radioactive atom is uranium, and uranium goes through this decay chain until it eventually reaches lead, and lead is stable. So if you pick up some rock and it's like pure uranium, then it probably came out of some like supernova. It was just like freshly created, right? But if it has a higher and higher proportion of lead, right, and you know like the half-lives of this whole chain process, then you can calculate like how old that rock is, like how long it's been turning from uranium into lead. Okay? And pretty consistently around Earth or in our wider solar system, we found rocks that looks like they're like 4.5 billion years old. So it seems like there's probably some nova or supernova event that happened 4.5 billion years ago that created all the planets in our solar system. All right, so back to here. If planet X has a similar story to Earth, let's look at where their civilization would be today. So like a time span. Right here. Oh, show this to you guys. I'm looking at here. Right. So showing like this timeline, right? So the universe starts say like here we go, this one, right? Say like the universe starts 14 billion years ago, billions of years passed, and then we got all these planets and stars like coming and dying in every which way, right? Then only like in the last 4.5 billion years did the Earth form, right? To get to present day, right? So we got these crazy timescales going on, right? It's not just the size of the galaxy or even the universe for like how many stars are out there, right? It's also that they've been coming and going. There's been opportunity for civilizations to come and go, like long before Earth even started, right? So the technology, back to the essay here, the technology and knowledge of a civilization only 1,000 years ahead of us could be as shocking to our world, to us as our world would be to a medieval person, right? Like if you go back 1,000 years ago, think about how crazy different society and technology was 1,000 years ago compared to now. But 1,000 years, like in the big scheme of things, is like nothing, right? We're talking about like dinosaurs died out like 60 something million years ago, right? A million, that's like 1,000,000. So um, a civilization 1,000,000 years ahead of us might be as incomprehensible to us as human culture is to chimpanzees. And if this hypothetical planet X, they could be like 3 point something billion years ahead of us. There's something called the Kardashev scale, which helps us group intelligent civilizations into three broad categories according to the amount of energy that they use. So we got a type 1, type 2, and type 3 civilization. A type 1 civilization has the ability to use all the energy of their planet. We're not quite a type 1 civilization yet, but we're getting close. Carl Sagan, who was the guy who was showing you guys Kepler's laws the other day, created a formula for the scale, which puts us at about, let's say, a type 0.7. A type 2 civilization can harness all the energy of their host star. Our feeble type 1 brains can hardly imagine how someone would do this, but we've tried our best imagining things like something called a Dyson sphere. So what if you had like a spherical shell around a star coated with solar panels and it collected all the energy from the star, right? Or what if it wasn't a shell? What if it was just like a series of satellites all orbiting a star, right? They were all collecting all the solar energy, got like huge amounts of energy you could do crazy things with. A type 3 civilization blows the other two away, accessing power comparable to that of the entire Milky Way galaxy. If this level of achievement sounds hard to believe, remember that this hypothetical purple planet X up there, and there are 3 billion years of further development. If a civilization on planet X were similar to ours and were able to survive all the way to type 3 level, the natural thought is they probably have mastered interstellar travel by now, possibly even colonizing the entire galaxy. Now, how would they do that? One hypothesis for how to colonize an entire galaxy is by creating machinery that can travel to other planets, spend 500 years or so self-replicating using the raw materials of that planet, so like maybe like terraforming and whatnot, and then send off 2 replicas to do the same thing. Right, so let me show you guys their diagram. I don't know how well it's going to show up. Actually, that was pretty good right there. You can see that. If you're watching this video at home, how good that looks betting. Class, we can kind of see it. Right? So we freeze that one. That one right there, right? Right. So here we got. You guys see the top picture on the top left? Say like there's a home planet. Say you send out a couple of probes. Say with some inhabitants, right? And they colonize like a couple planets, and then right, repeat that process, but in iteration steps of like hundreds of years, right? So every 500 years, it's like, let's do the same thing, right? And so how long would that take to colonize an entire galaxy? I mean, entire galaxy is like 100 billion stars, right? So it would take a long time. Well, don't forget exponential growth, right? Which our brains have trouble grappling with. Even without traveling anywhere near the speed of light, that process could colonize the whole galaxy in less than 4 million years. A relative blink of an eye when talking about the scale of billions of years. Like 4 million years, again, that's nothing compared to like the wider picture of how much time has been passing. Right? I mean, dinosaurs died out 65 million years ago. And that was the last major extinction. The Earth has had like several major mass extinctions, right? The one that killed out the dinosaurs was actually the 5th mass extinction, and that wasn't even considered to be the biggest mass extinction, right? We're going through a mass extinction right now. We're going through the 6th one right now. So these things are like tens of millions of years apart, right? And it would only take about 3 or 4 million years to colonize an entire galaxy with this method, right? Go to the planet, wait 500 years, go to the next planet, 500 years, right? Because of exponential growth. Continuing to speculate, if 1% of intelligent life survives long enough to become a potentially galaxy colonizing type 3 civilization, our calculations above suggest that there should be at least 1,000 of these type 3 civilizations just in our galaxy alone. And given the power of such a civilization, their presence would likely be pretty noticeable. And yet, we see nothing, hear nothing, visited by no one. So, where is everybody? And this is the Fermi paradox. We have no answer to the Fermi paradox. The best we could do is possible explanations. And if you ask 10 different scientists, was their hunch about the correct one, you'll get 10 different answers. When you hear about humans of the past debating about whether the Earth was round or if the sun revolved around the Earth, or thinking that lightning happened because of Zeus and thinking, oh, that all seems so primitive and in the dark. That's about where we are on this topic. And taking a look at some of the most discussed possible explanations for the Fermi paradox, let's divide them into two broad categories. Those explanations that assume that there's no sign of these type 2 and 3 civilizations because there are none of them out there. And then another category, it says that maybe they are there, but we're not seeing or hearing from them for some other reason. So there's like 15, 20 different explanations that I'm about to go through. So we're starting like a new section of this essay, right? We're going to get into speculation like why we wouldn't be seeing these other life forms. Okay. Explanation group 1 is that there are no signs of higher level civilizations because they don't exist in the first place. Right? And then later on, we'll get to like, what if they do exist, but somewhere there. Right? So those who just subscribe to group 1 explanations point to something called the non-exclusivity problem, which rebuffs any theories that says there are higher civilizations, but none of them made any kind of contact with us because they all fill in the blank. Group 1 people look at the math, which says that there should be so many thousands or millions of higher civilizations that at least one of them would be an exception to the rule. So even if a theory held for 99.99% of higher civilizations, the other 0.01% would behave differently and we would become aware of their existence. So, for example, one of the explanations like way later on this essay is something called zoo hypothesis. So like, what if there's a bunch of intelligent aliens that are looking at us Earth saying like, oh, let's leave them isolated and not touch them because it's very rare that we ever get to see civilization develop technology. We're watching the humans do it. So let's do a hands-off approach and see like how this actually happens, right? Well, if there's like millions of beings that have the opportunity to like make contact with us, someone's going to break the rule and come visit the Earth. It is how the explanation goes. Okay? Therefore, say group 1 explanations, it must be that there are no super advanced civilizations. Since the math suggests that there are thousands of them just in our own galaxy, something else must be going on. That something else is called the Great Filter. The Great Filter theory, here, I'll give you guys a graphic for those two. Great Filter. Here. Great Filter. Freeze that. Oh, no, sorry. Hit freeze. There we go. Froze that picture. Great Filter theory says that at some point from pre-life to type 3 intelligence, there is a wall that all or nearly all attempts at life hit. There's some stage in the long evolutionary process that is extremely unlikely or impossible for life to get beyond. That stage is the Great Filter. If this theory is true, the big question is, where in the timeline does the Great Filter occur? It turns out that when it comes to the fate of humankind, this question is very important. Depending on where the Great Filter occurs, we're left with 3 possibilities. We're rare, we're first, or we're headed for inevitable disaster. Okay, so this essay has like different subcategories to it. It's like a giant branching, right? So now we're going like a layer deeper, right, to these 3 categories within this first group 1 explanations. Okay. So explanation 1, we're rare. That's to say that the Great Filter is behind us. Right? It's like if we somehow, like on that green line that goes like way off to the right. One hope that we have is that the Great Filter is behind us, that we've managed to surpass it, which would mean that it's extremely rare for life to make it to, say, like our level, where we have technology. Oh, yeah, go. Oh, yeah, go. We have technology and that adds on itself and the whole thing. The diagram below, okay, so they go. Diagram shows only say some number of species making it past for one. Actually, they got a slightly different diagram here, but it's basically the same thing as what you guys are looking at. That scenario would explain why there are no type 3 civilizations, but it would also mean that we could be one of the few exceptions now that we've made it this far. It would mean that we have hope. On the surface, it sounds like a bit like people 500 years ago suggesting that the Earth is the center of the universe and implies that we're special. However, something scientists call the observation selection effect suggests that anyone who is pondering their own rarity is inherently part of a an intelligent life success story, whether they're actually rare or quite common, the thoughts that they ponder and conclusions they draw will be identical. This forces us to admit that being special is at least a possibility. And if we are special, when exactly did we become special? Which step did we surpass that almost everyone else gets stuck on? Right. So then it goes into, okay, now we got another subcategory. Right. So one possibility, a great filter could be at the very beginning. It might be incredibly unusual for life to begin at all. This has to be a candidate because it took about 1 billion years of Earth's existence for this to finally happen. And we have tried extensively to replicate that event in the laboratory and never been able to do it. If this is the great filter, it would mean that not only is there no intelligent life out there, there might be no other life at all. Right. So remember how Earth is, say, about 4.5 billion years old, right? Well, the first like billion years or so, I mean, it probably was not very conducive to life anyway. You have got like volcanoes and crazy all over the place, right? Eventually, the Earth kind of settles down, becomes more temperate. Uh, and then when the first life does develop, first, I think like a couple billion years is just basically bacteria. Right? Oh, and this whole thing about trying to create life in the laboratory. Scientists are trying to figure out like what was the early atmosphere like. Say if you go back 2-3 billion years ago, what was the atmosphere like? They have some good hunches and some good data for what that would be. Right? And they've created laboratory conditions for like what the atmosphere was like. It didn't used to be oxygen rich. Right? Oxygen only came about, I think, after like plants started to form. Right? So they created the early conditions for life, and then did some chemical reactions, and there were like amino acids that would naturally be created in those like early atmosphere type conditions. Amino acids, you guys know, are like building blocks for um, like proteins and stuff, right? So that we have in us, right? So that'd be like one important step, but we've never been able to just like create like actual life from scratch in a lab. Right? Another possibility, the great filter could be the jump from simple prokaryote life to complex eukaryote cell. After prokaryotes came into being, they remained that way for almost 2 billion years before making the evolutionary jump to being complex and having a nucleus. If that's the great filter, it would mean that the universe is teeming with simple prokaryote life cells and almost nothing beyond that. Maybe the universe is full of basically bacteria. You guys learn in biology that you actually have two different sets of DNA, right, in each of your cells. Right? You have the like your main DNA, and you also have mitochondrial DNA. Right? You guys learned about that, right? So what probably happened, like the main running hypothesis, again, nobody knows for sure, right? But what probably happened about a couple billion years ago was that maybe there were two different kinds of bacteria-like cells, and maybe one consumed the other, but instead of digesting it for energy, maybe what happened instead is it incorporated it like in some symbiotic type relationship. And one of those beings ended up becoming mitochondria, so it's really good at processing energy. And the other being became basically everything else that's structural. Right. So now we're able to like breathe oxygen and use that energy. Right? So we're able to metabolize energy, right? Because we have these eukaryotic cells. There are a number of other possibilities. So back to this essay. Some even think that the most recent leap we've made to our current intelligence is a great filter candidate. While the leap from semi-intelligent life, think chimps, to intelligent life, think humans, might not at first seem like a miraculous step. Steven Pinker rejects the idea of an inevitable climb upward of evolution. Since evolution does not strive for a goal but just happens, it uses the adaptation most useful for a given ecological niche. And the fact that on Earth this led to technological intelligence only once so far, well, basically, I mean, there are some animals that have been seen to use like basic types of technology, famously, I think like crows will do things like if there's water in a cup and they can't reach down and drink the water, they'll actually like pick up stones and drop the stones in the cup to raise the water level. I mean, that's a basic type of tool use or technology, right? But not like additive technology, right? So I don't think there's any like clear case of animals like developed technology and the next generation taking that technology and building on it to make more technology, right? Now humans do that, right? Like nobody invented a computer from scratch. That comes from like thousands of years of history that led up to that point. Right? This led to technological intelligence only once. So far, suggests that this outcome of natural selection is rare and hence by no means a certain development in the evolution of a tree of life. Most leaps do not qualify as great filter candidates. Any possible great filter must be a 1 in a billion type thing where one or more total freak occurrences need to happen to provide a crazy exception. For that reason, something like the jump from single cell to multi-cell life is ruled out because it's occurred as many 4 to 6 times in isolated instance on this planet alone. For the same reason, if we were to find a fossilized eukaryote cell on Mars, it would rule out the simple complex cell leap as a possible great filter candidate, as well as anything before that evolutionary chain. Because if something happened on both Earth and Mars, it's almost definitely not a 1 in a billion freak occurrence. Okay. If we are indeed rare, it could be because of a fluky biological event, but it could also be attributed to what's called the rare Earth hypothesis, which suggests that although there might be many Earth-like planets, the particular conditions of Earth, whether it's related to, say, like the specifics of our solar system, so example that might be like the fact that there's a giant planet Jupiter out there that's basically vacuuming up a bunch of asteroids that might otherwise hit us. Right? Maybe our relationship with our moon. Our moon is unusually large for a planet of our size. It contributes to, it says, particular weather and ocean conditions. Yeah, it helps stabilize Earth's orbit on its axis. Or maybe something about the planet itself or is exceptionally friendly to life. Right? So we might look at other planets and say like, oh, there's a planet like so far off in our galaxy that like probably has liquid water and is in a habitable zone that seems Earth-like. Maybe there's something about our planet that we're kind of overlooking or taking for granted that makes life particularly conducive. Okay. Possibility 2, we're first. For group 1 thinkers, if the great filter is not behind us, one hope that we have is that the conditions in the universe are just recently, for the first time since the Big Bang, reaching a place that would allow intelligent life to develop. In that case, we and many other species may be on our way to superintelligence, but it simply hasn't happened yet. We happen to be here at the right place at the right time to become the first or one of the first super intelligent civilizations. One example of a phenomenon that could make this realistic is the prevalence of gamma ray bursts, insanely huge explosions that we've observed in distant galaxies. In the same way that it took Earth a few 100 million years before the asteroids and the volcanoes died down for life to even become possible, it might be that the first chunk of the universe's existence was full of cataclysmic events like these gamma ray bursts that would incinerate everything nearby from time to time and prevent life from developing past a certain stage. Now, perhaps we're in the midst of an astrobiological phase transition, and this is the first time that life has even had the chance to evolve for this long uninterrupted. Right? So, yeah, there's like some like star that went crazy, and there was some gamma ray burst, and these are like directional. So if it happened to be directed right at us, these would move at pretty well the speed of light. So we wouldn't even know, until like hit us, and then like just one day like we look up in the sky and our atmosphere gets blown off. Boom! Happy birthday. Possibility 3. We're headed for inevitable disaster. Maybe the great filter actually is ahead of us. So going back to what you guys are seeing on that frozen screenshot right there. Maybe we're in this whole like web of mess before that red line, and there's something that's about to happen that's going to wipe us all out. Here, read this and then about this a little bit. If we're neither rare nor early, Group 1 thinkers conclude that the great filter must be in our future. This would suggest that life regularly evolves to where we are, but something is preventing life from getting much further and reaching high intelligence in almost all cases, in which case we're unlikely to be an exception. One possible filter, one possible future great filter is a regularly occurring cataclysmic natural event like the aforementioned gamma ray bursts, except that unfortunately they're not done yet. It's just a matter of time before all life on Earth is suddenly wiped out by one. Another candidate is the possible inevitability that nearly all intelligent civilizations end up destroying themselves once a certain level of technology is reached. This is why Oxford University philosopher Nick Bostrom says that, quote, no news is good news. The discovery of even simple life on Mars would be devastating because it would cut out a number of potential great filters behind us. And if we were to find fossilized complex life on Mars, side note here, Mars, say like about 1 billion years ago or so, right? used to be more Earth-like. It used to have liquid water on it in an atmosphere. We know that because if you look at geological formations on the surface of Mars, you actually see water erosion, right? So what probably happened is that Mars used to be more Earth-like, I mean colder, but Earth-like. And then uh, over time, because it's a smaller planet than Earth, its core froze over. We used to have probably a molten core that eventually cooled off and froze over. Right? And when that happened, it probably lost its magnetosphere. You guys know if you use a compass, then a point north, because the Earth is basically a giant magnet. Right? And once you lose your magnetosphere, then the solar wind from the sun will pick off your atmosphere and basically erode your atmosphere. So does Mars have an atmosphere? Yeah, but barely, right? Its atmosphere is like, I think less than 1% of Earth's atmosphere. And so, but they used to have, right? So it used to be more Earth-like, but no longer, right? And so what if we were to find this like evidence of prior life on Mars, right? That would be by far the worst news ever printed on a newspaper cover, because it would mean that the great filter is almost definitely ahead of us, ultimately dooming our species. Bostrom believes that when it comes to the Fermi paradox, quote, the silence of the night sky is golden. Yeah, so you guys can probably think of some examples of what these technologies might be. One example, like going back decades, going through the Cold War, might be something like nuclear technology, right? Like throughout history, like anytime there was a technology that was developed, it always was eventually incorporated into war. And for nuclear weapons, like the only example of like war use was, of course, at the end of World War II when we dropped two bombs on Japan. But in the Cold War, everybody was that was a possibility hovering over the world for decades, right? Okay, well, it's just a matter of time before things get out of control and the whole world goes nuclear and we all kill each other. Right? No, never came to that, but still a possibility, right? Other examples are, I mean, even just the recent artificial intelligence, right? So like AI. So some developers of AI just in recent years had to think, well, this is a technology that can also build on itself, right? So if AI like reaches a certain point, what if it just starts like improving itself, which basically already does, right? So an artificial intelligence machine can look at its own programming and like recode itself to create like a better version of itself, and then it's just a huge like exponential takeoff. Right? So a lot of the developers of AI said, well, let's definitely not give it access to like actual like machinery, like robots, where it could just like program itself into a robot and start running around creating havoc. Let's also not ever put it on the internet where it could like access like all the information and start creating crazy stuff. Now we've definitely passed that threshold, right? And another possibility, one of these technologies is just something like genetic engineering, right? There have been some actually close calls in history of like, what if you develop some bacteria that like runs away and starts like consuming everything, right? So like, oops, right? Or some virus or something, right? Which maybe COVID is kind of like a light example of that. But what if you created like a COVID AIDS or something crazy, like oops, right? Explanation group 2, type 2 and 3 intelligent civilizations are out there, but there might be some logical reason why we might not have heard from them. Right. So we're going from a group 1 thinking to group 2 thinking here. Now, group 2 thinkers are more like, well, okay, there might be aliens, but why are we not hearing from them? So group 2 explanations get rid of any notion that we're rare or special or the first at anything. On the contrary, they tend to believe in something called the mediocrity principle, whose starting point is that there is nothing unusual or rare about our galaxy, our solar system, our planet, our level of intelligence, until evidence proves otherwise. They're also much less quick to assume that the lack of evidence of higher intelligence beings is evidence of their non-existence, emphasizing the fact that our search for signals stretches only about 100 light years away from us, 0.1% across the galaxy, and suggesting a number of possible explanations. Here are 10. I don't know if I'll have time to read all 10 in the rest of the class time, but we'll go as far as we can. Right? Possibility 1. Okay, so 1 out of 10. Right? Possibility 1. Super intelligence, intelligent life could well have already visited Earth before we were here. In the big scheme of things, sentient humans have only been around about 50,000 years, or I don't know, I've seen up to maybe a 250,000 years, a little blip of time. If contact happened before then, it might have made some ducks flip out and run into the water, and that's about it. Further, recorded history only goes back about 5,500 years. So some ancient group of hunter-gatherer tribes might have experienced some alien interaction, but had no good way to tell anyone about it. Like if it's 7,000 years ago and the aliens visit some tribe, it's like, okay, well, how are they going to write it down? Writing has been invented. Possibility two, the galaxy has been colonized, but we just live in some desolate rural area of the galaxy. For example, the Americas may have been colonized by Europeans long before some small Inuit tribe in far northern Canada had realized that this had happened. There could be an urbanization component to the interstellar dwellings of higher species in which all the neighboring solar systems in a certain area are colonized and in communication. And it could be impractical and purposeless for anyone to deal with coming all the way out to Earth in some random part of a spiral where we happen to live. Possibility three, maybe the entire concept of physical colonization is a hilariously backward concept to a more advanced species. Remember that, like the example of a Dyson sphere, like around a star. I mean, if you could capture like most of the energy from a star, that'd be a crazy amount of energy. And with all that energy, it might be that you've created the imperfect environment for yourselves that satisfies your every need. There might be crazy advanced ways of reducing need for resources and zero interest in leaving a happy utopia to explore a cold, empty, undeveloped universe. An even more advanced civilization might view the entire physical world as a horribly primitive place, having long ago conquered their own biology and uploaded their brains to a virtual reality, eternal life paradise. Living in the physical world of biology, mortality, wants, needs, might possibly seem to them the way we view primitive ocean species living in a dark, frigid sea. Possibility four. Actually, these next few possibilities is a similar idea, so maybe I'll just read one of these. There might be a scary predator civilization out there, and most intelligent life knows better than to broadcast any outgoing signals to advertise their location. This is an unpleasant concept and would help explain the lack of any signals being received by SETI satellites. It might also mean that we're being super naive newbies who are being unbelievably stupid and risky by ever broadcasting outward signals. There is a debate going on as to whether we should engage in METI, messaging to extraterrestrial intelligence, the reverse of SETI, search for, right? Or not. And most people say that we should not. Stephen Hawking warns, if aliens visit us, the outcome would be much as when Columbus landed in America, which did not turn out well for the Native Americans. Even Carl Sagan, a general believer in that any civilization advanced enough for interstellar travel would be altruistic, not hostile, called the practice of METI deeply unwise and immature, and recommended that the newest children in a strange and uncertain cosmos should listen quietly for a long time, patiently learning about the universe and comparing notes before shouting into an unknown jungle that we do not understand. See, possibility five is kind of similar to that one, so I'm gonna skip that one. Possibility six, maybe there is plenty of activity and noise, but we're just listening for the wrong things. Maybe our technology is too primitive, right? Like a lot of our technology right now is like you guys can send text to each other with cell phones, right? To someone say like 500 years ago, that wouldn't make any sense. Like, what does that even mean to send a text through a cell phone, right? Right. But that's only 500 years ago, which again, it's like little bit of time, big scheme of things. So, how are people going to be communicating with each other like 500 years from now? It's probably something that's unfathomable to us, right? What about like 1,000 years from now, or 10,000 years from now, or 1,000,000 years from now? Right? Okay, so skip ahead a little bit. Possibility eight: higher civilizations are aware of us and observing us. Something called the zoo hypothesis. As far as we know, superintelligent civilizations exist in a tightly regulated galaxy, and our Earth is treated like a part of a vast and protected national park with a strict look but don't touch rule for planets like ours. We wouldn't notice them, because if a far smarter species wanted to observe us, it would know how to do so without us even realizing it. Maybe there's a rule similar to Star Trek's Prime Directive, which prohibits superintelligent beings from making any open contact with a species like us or revealing themselves in any way until they've reached some particular level, right? Maybe they got some checklist like, oh, if they don't reach this level of technology or this level of understanding or like how to interact with each other, play nicely, or oh, there's so launch some words against each other, right? Right, like that. There's a couple other possibilities. Let's do possibility 10. Maybe we're completely wrong about our reality, right? Maybe we're all like programmed in some computer simulation. It's called, simulation hypothesis. You may have heard of maybe something like that, right? Right. So then conclusion. It's got a few paragraphs of conclusion. So just go ahead and read as far until the bell. Right. As we continue with our possibly futile search for extraterrestrial intelligence, I'm not really sure what I'm rooting for. This is Tim Urban, of course, the author. Frankly, learning that we're either officially alone in the universe or we're officially joined by others would be creepy, which is a theme with all of the surreal storylines above. Whatever the truth actually is would be mind-blowing. Beyond its shocking science fiction component, the Fermi paradox also leaves me with a deep humbling, not just the normal, oh yeah, I'm microscopic and my existence lasts for 3 seconds humbling that the universe always triggers. The Fermi paradox brings out a sharper, more personal humbling, one that can only happen after spending hours of research hearing your species' most renowned scientists present these insane theories, change their minds over and over again, wildly contradict each other, reminding us that future generations will look at us the same way we look at ancient people who were sure that the stars were the underside of a dome of heaven and think, wow, they really had no idea what was going on. Compounding all of this is the blow to our species' self-esteem that comes with all this talk of type 2 and 3 civilizations. Here on Earth, we're the king of our own little castle, proud ruler of a huge group of people who share the planet with us. And in this bubble with no competition and no one to judge us, it's rare that we're ever confronted with the concept of being dramatically inferior species to anyone else. But after spending a lot of time with these type 2 and type 3 civilizations, right, hypothetically, our power of pride could be seeming a bit David Brent-esque. I had to look up that reference. Apparently, it's a reference to the UK version of The Office, I guess their version of Michael Scott. So someone has, I guess, this like huge ego that kind of outsized and not a. That said, given my normal outlook, given that my normal outlook is that humanity is a lonely orphan on a tiny rock in the middle of a desolate universe, the humbling fact that we're probably not as smart as we think we are, and the possibility that a lot of what we're sure about might be entirely wrong, sounds wonderful. It opens the door just a crack that maybe, just maybe, there might be more to this story than we realize. There you go. Hope you guys enjoy Fermi Paradox. All right, so you guys have a great afternoon. I'll see you guys tomorrow.